Hi, welcome to my first devlog where I'm going to go through setting up a VR project for Unity. So from the Unity hub I have clicked on Create Project, and I'm going to core and URP, that's the Universal Render Pipeline. The Universal Render Pipeline is designed with mobile chipsets in mind and has optimized for lower end devices. Now, for my virtual reality project, I'm going to be aiming at the Oculus Quest and Quest 2 and compatible devices. So URP just generally makes a bit more sense for me for that. So I selected that. I have all of my Unity projects in a folder on my SSD drive for speed, and I'm just going to call this VR template for now. And create a project. This will take a couple of minutes or two, so I'll just fast forward through that. So now that our project has been created, let's close the hub. We can start to look at the settings that we need to change to make this suitable for mobile VR. So the very first thing I'm going to do is I'm going to come up to Window and Asset Management. Package Manager. In here are the list of packages that are currently in my project, and I'm going to start by removing a few that I don't use at the moment. So I'm not using JetBrains Rider, which is an IDE for code. I'm also not using Unity's built-in version control. I'm using GitHub for desktop. So now that my packages are installed there, I'm going to come to File, Build Settings, and Player Settings. Looking down the list, the project settings in Unity, to some people, especially when you're first starting, can be quite intimidating, but they are fairly logically grouped together. And VR comes under the general heading of XR, Extended Reality. So we'll start here. It's asking us to install an XR plugin management. We click on that, and the plugin manager will then let us choose from various XR and VR backends that interface with Unity once that's set up. So I'm going to be building for both desktop and for Android. Android is the operating system for the Quest and Quest 2. So under here I'm going to select OpenXR, and that will install the plugin for OpenXR. and I'll go through why we're using the OpenXR framework or plugin provider in just a moment. This will say that we're using the new input system package, which in my humble opinion is a big improvement on the old one, so we'll need to restart the editor. So just click yes. Now that this has opened back up, we can come into our XR management, make sure that it is selected for both of our platforms, and you'll see there's a little warning symbol next to it. And to correct that, we just come down into OpenXR, and it's going to ask us firstly for an interaction profile. And it'll say the list is empty. By interaction profile, it really means the controllers that we'll be using. So obviously for the Oculus Quest system, that's going to be Oculus Touch. And we're also going to want to enable Oculus Quest support in this list of features. Come back here, do the same for my desktop. Okay. And that part is complete. So with that installed, we should just be able to come into a scene, set the camera up for VR, but the easier way, if you're just trying to get started quickly, is if we look in the Unity registry and we come under VR, we'll see there is the XR Interaction Toolkit. Now, the XR Interaction Toolkit doesn't depend on any particular framework. It just provides a base suite of prefabs and scripts that will make life a little bit easier to get started. So, come over to install. And it will say, okay, this will be changing some of your project settings. So as this is a clean system, we don't really need to worry about that too much. So close off my project manager. There are some other settings that we need to change in the build settings. If I come over here to firstly talk about why we're using OpenXR. So OpenXR is a product of the Kronos Group, and the Kronos Group is a selection of companies and organisations that support an open platform for virtual and extended reality. Looking through the list of members already, you'll see that there are some very big names: Tencent, Valve, NVIDIA. Coming down through the contributor members, we'll also see Meta, obviously for the Quest range of headsets, and an awful lot of others, including Unity. If we come into the Oculus developer guidelines for getting started with Unity, you'll see that it says to accelerate OpenXR adoption, Meta has made the OpenXR runtime the default and preferred backend. So although there is an Oculus XR setting available for us in here, they themselves are saying to use the OpenXR. Now, if you wanted to take make use of all of the Oculus features, including some of the experimental features, you would need to use the Oculus plugin and the Oculus integration package, which can be found in the asset store and then added in through the asset manager. but for the majority of use cases, the OpenXR will be the preferable one. Coming to the guidelines in here, there are various settings in here, so if you follow this through, you'll probably end up in a very similar place to where I'm showing you now. One of the caveats I will say is, if we look through here and look at things like testing and analysis and additional settings, some of the settings have changed in Unity over time. So where it may say to do something in here, you may find that that hasn't been removed in Unity 2021.3, but it may have moved menus. So coming back to my template and coming back to my project settings, one of the things that we'll need to do is adjust the quality and graphic settings. So if I come down to quality, you'll see that there are 3 levels by default. High fidelity for PC only, and balanced for and performant for Android. We're going to want to use balanced for Android, and we're going to want to make a few changes. So first of all, VSync. We don't need to enable VSync for the Oculus Quest or OpenVR because it handles synchronization itself inside the plugin. Texture quality we're going to want to keep at full resolution, and anisotropic textures set to per texture. So billboards facing camera position is also one of the other recommendations, and to keep the cost of animation down, we can change that from 4 to 2, although that may change for your project settings if you need more quality for your animations. So looking at the balanced universal render pipeline settings, we can see that we can find that in our project setting here, and we can make some changes to this whilst we're here. So where it says HDR, we can disable that. The Oculus Quest does not include HDR as part of its display, and anti-aliasing recommended by Oculus to be set ×4. So lighting per pixel and additional lights, Oculus recommends that you only have 1 per pixel main light, but we can soften the impact of that somewhat by having a per vertex additional light, although this will have a performance impact. So shadows and post-processing, max shadow distance. Obviously this is very dependent on your game. I normally reduce this down if I'm working with indoor scenes, and leave it roughly where it is if I'm working with an outdoor setting. Cascade count, leave it at 1, and last border, these settings are about right. Soft shadows can have quite a performance impact, so try that with your profiling off and on. Post-processing, low dynamic range, and you can just leave those at default. We won't be wanting to use a lot of post-processing, if any at all, in our global volumes for our scenes. So we have set our quality setting, we have set our graphics setting, anything else in there that I can consider at the moment? No. Audio, there is a spatializer available if you install the Oculus integration. You don't have to use the whole of the integration, but you can use the spatializer, and that will allow better virtual reality sound at a small performance hit. It will also allow you to do ambisonics, which is playing a sound source that contains many different individual sound sources that appears as if it's within a sphere. Do have a look at that if audio quality is important for your particular use case. So other things, physics. If you are using a physics-based game, games like Boneworks or Half-Life Alyx make excellent use of physics, although it can be quite costly in VR as we're working with a mobile platform. And you're going to want to increase the physics time step within here to match your frame rate. Most games will be set at kind of default for a normal 60 FPS flat screen game, so coming in here, changing the solvers and the time steps, maximal and allowed time steps in here to reflect what's going on for VR. Again, just be careful with that, they can be quite costly. So the only other thing that I will show you here is we have our default simple scene that comes with a global volume for universal renderer pipeline that has things like tone mapping, bloom vignette, and these are all things that we would expect to see in a 2D game or a flat screen game. And there are other post-processing things we could add, so depth of field effects and things like this, but these are all horrendously expensive for virtual reality games. So the general recommendation is not to use post-processing for mobile virtual reality. So I'll get rid of that. Coming back to our scene, I'm just going to throw down a floor. So create a 3D cube, extend it out a little bit, and say 20 by 20. And as you can see, we have a main camera in here already, but what we can do is come to XR, and it will give us various options for here. So an XR controller, action-based rather than device-based. Action-based uses the new input system, whereas device-based uses the old. And we can just put in an XR controller. Component. Sorry, game object, XR. And within this you can see, sorry, they've renamed that since last time I looked. You'll see that it has removed the original camera. We now have an origin. If you're using the Quest, the origin would be the place within your play space where you're standing, and we can say set that to the floor. So if you're using the Quest, you calibrate where the floor is, and that's pulled through in there. We have our main camera, very similar settings to what you'd expect, but we also have tracking on the headset. So with that in place, the other thing you need to set up if you haven't already is how your PC connects to your Quest. If you have a headset cable and you're connecting via headset cable to play PC VR games, then you only need to open up your Oculus, plug your headset in, and that will take you through. If you're using Wi-Fi for your headset, please do make sure that your PC is plugged into the router that is providing your Wi-Fi, otherwise you'll get an atrociously bad frame rate. And then once you have done that, you can quite literally have your headset and controllers ready to go and click play to preview in your scene. If you wish to plug your controller in, you will need to plug your controller in to do builds. You can come to your build settings for Android and set the device. Your Quest will show up there once it's plugged in, and build through from there. Okay, thank you very much. In my next devlog, I'll be talking about frameworks, the frameworks that I have looked at and reviewed for my project, and to kind of look and see what is suitable based on my needs. I'll also go through some of my gameplay story and highlight why I've chosen a particular framework in terms of how it meets my needs and how one could work for yours. Thank you very much. That's it.